Hi, in this video we will take a look at the driving factors that have companies adopting cloud computing. After that we will take a deep dive into the concept of green computing. Driver 1, cost reduction and efficiency gain. Driver 2, using existing investments while extending infrastructure. Driver 3, speed of change. Driver 4, innovation. Driver 5, security, compliance, and regulatory requirements. Driver 6, the environment. Companies are always looking for ways to reduce their costs. Cloud computing is more cost-effective than having a traditional IT infrastructure. With a traditional infrastructure, companies have to buy their own servers, set them up, and pay personnel to maintain them. This infrastructure must also have a larger capacity than the company uses on a day-to-day basis. Cloud computing solves these issues by storing the hardware for the company and only charging for the amount of data the company actually uses. A company that has already invested in their local infrastructure can keep using that infrastructure in conjunction with cloud computing for any future expansions. This allows them to eventually start using the capacity of their local infrastructure and start using the flexibility of cloud computing for any future expansions of that capacity. Companies can have a hard time keeping up with the changes in hardware. For example, if a new CPU or GPU is released, a company will have to change their local infrastructure to use these, which is often a costly move. Most companies will therefore keep using outdated hardware. Since a cloud provider can in most cases provide that hardware, this responsibility is something the company now no longer needs to worry about. With the increasing demands of customers, some companies may have a hard time keeping up with those demands. For example, most customers nowadays want access to your application from their mobile device, or use big data in some way to analyze their data. Cloud computing allows the company to more easily satisfy these demands by offering a quick increase in computing resources. Cybersecurity and regulatory standards are becoming more complex and now require companies to invest a significant amount of time and resources to these issues. Cloud computing, with its standardization of resources, automation of deployments and built-in security features, will allow companies to more easily satisfy these standards and keep their clients' data safe. With an escalation of the panic surrounding the environment and other ecological issues, companies must now be aware of how much resources are being wasted in their computing. By using cloud computing, a large part of this issue is taken away from the company and put on the cloud provider, who often has more advanced techniques to reduce waste.
Hi, we will now talk about green computing. This means we will talk about cloud computing in relation to being environmentally friendly. With the recent attention of the world's nature being more damaged than we thought and the ongoing global warming protests all around the world, it is necessary to look at the environmental side of cloud computing. Cloud service providers are making significant investments in data center infrastructure to provide not only raw computing power but also software as a service business applications for their customers. New data centers are being built at ever larger scales and with increased server density, resulting in greater energy consumption and carbon production. The Smart 2020 Report 4, Enabling the Low-Carbon Economy in the Information Age, estimates that the environmental footprint from data centers will more than triple between 2002 and 2020, making them the fastest-growing contributor to the ICT sector's carbon footprint. While the big push for environmentalism originates from the 70s and 80s, we see a dedicated organization for environmental challenges in IT for the first time in 1992, when the Environmental Protection Agency launched Energy Star, a voluntary label that companies could apply. This was meant to be used to show their practices were clean. Green Star as an organization is also often credited with being the reason that PC monitors have a sleep mode to reduce power consumption. Brands are keen to show their ecological friendly labels on their products. So you can see that sometimes the simplest of things can help the environment. In 2018, 3 new US patents make use of facilities designed to simultaneously cool and produce electrical power by use of internal and external waste heat. For a long time, these types of waste heat haven't been used in many cases. The new patents set a standard for how to deal with these types of heat. The 3 patents use silo design for stimulating use of internal waste heat, while the recirculation of the air cools the silo's computing racks. The first patent uses the recirculating air for power generation, while the second patent forces the recirculation of the same air, and the last patent uses thermal differences in temperature resulting in negative power usage effectiveness. Power usage effectiveness is the ratio that describes how efficiently a computer data center is. This gives an insight in how much energy is used by the computing equipment without taking cooling and other factors in consideration. PUE was originally developed by the consortium called the Green Grid. You will see this PUE ratio again when we talk about data center design.
The Smart 2020 report, Enabling the Low-Carbon Economy in the Information Age, estimates that the environmental footprint from data centers will more than triple between 2002 and 2020, making them the fastest-growing contributor to the ICT sector's carbon footprint. Several key factors enable cloud computing to lower energy use and carbon emissions from IT. Forecasting and ongoing adjustment of allocated capacity avoids unnecessary over-allocation of resources and sizing close to actual usage. The desire to avoid ongoing capacity adjustments as demand fluctuates over time. Difficulty in understanding and predicting demand growth and peak loads. Budget policies that encourage using all available funds in a given year to avoid smaller allocations the following fiscal year. Sharing application instances between client organizations, tenants, flattens peak loads and reduces overhead for tenant onboarding and management. Just as multiple tenants in an apartment building use less power overall than the same number of people owning their own homes, so do the multiple tenants of a cloud-provided infrastructure reduce their overall energy use and associated carbon emissions. The cloud architecture allows providers to simultaneously serve multiple companies on the same server infrastructure. Large deployments of virtualized server infrastructure serving multiple tenants can balance compute and storage loads across physical servers and thus be operated at higher utilization rate. Large deployments of virtualized server infrastructure serving multiple tenants can balance compute and storage loads across physical servers and thus be operated at higher utilization rates. Cloud computing can drive energy savings by improving server utilization. As large-scale cloud providers tend to run their infrastructure at higher and more stable utilization levels than corresponding on-premise operations, the same tasks can be performed with far fewer servers. Whereas a typical on-premise application may run at 5 to 10% average utilization rate, the same application in the cloud may attain 40 to 70% utilization, thus dramatically increasing the number of users served per machine. Industrialized data center design at scale and optimized for power efficiency reduces power wasted on cooling, UPS etc. and allows running servers at optimal utilization and temperature. Data center design, the way facilities are physically constructed, equipped with IT and supporting infrastructure, and managed, has a major impact on the energy use for a given amount of computing power. Thank you for watching our video.